The concept of a nuclear-powered airplane engine is presented, representing the most recent advancement in aviation technology. The vast power of nuclear energy is combined with airplane propulsion technologies in this cutting-edge breakthrough that might radically alter the way we fly. This idea has the potential to usher in a new age of environmentally responsible long-distance travel because of its promise of increased efficiency and range. Is the future of flight up for grabs if we embrace nuclear power? Is it a glimpse into the future, or a probable apocalypse? How does this technology work, and how does it differ from the traditional way? Let's find out. Decades have passed since the discovery of nuclear power and the discovery of Oppenheimer, who invented the atomic bomb. While a few useful implementations made it into widespread use, many promising advantages lagged well behind the state-of-the-art, until at least the year 2020. Even in the immediate aftermath of World War II, the US Navy has successfully used nuclear power to propel its ships, whereas the Air Force has long fantasized about the potential of nuclear-powered planes. However, it seemed unfathomable to pack the immense power of a nuclear reactor into an engine the size of a fighter plane. But there is now an opportunity to create the long-awaited nuclear-powered aircraft, and we're about to tell you all the ins and outs. Nuclear energy was a hot topic 50 years ago. In those days, it was used to power anything from cars to airplanes. Humanity's discovery of nuclear fission and the enormous quantities of energy it created changed the world. A variety of uses for firefighters, bombers, and scout planes that functioned well on very little gasoline started costing a lot more. It would allow the industry to fly endlessly with unlimited airtime. Unfortunately for the military, atom-splitting reactors were not as simple as they had hoped. It's too dangerous to soar above 50,000 feet. Nonetheless, advancements in fission have submarines and supercarriers fueled by nuclear reactors have made their way into naval equipment. The nuclear slam missile developed for Project Pluto and other aviation initiatives, including the nuclear-powered Convair NB-36 bomber, is laughable by today's standards. First of all, the slam missile, according to Project Pluto's experts, would have completely destroyed everything in its path, even without the radiation. The cacophony was too much for it to take, and it gave up and flew away. The NB-36 could have stayed in the air for about the same amount of time, indefinitely, but maybe at the expense of a catastrophic ecological calamity. Despite previous evidence to the contrary, expectations were revived for a nuclear-powered aircraft in 2018. However, the procedure would be reversed this time around. Nuclear fusion is a physical process that, like fission, generates enormous quantities of energy from individual atoms. The first, however, necessitates the disintegration of a whole atom into its constituent parts, while the latter combines two relatively light atoms into a single, denser one. There is no danger of a meltdown in a fusion reactor. Nevertheless, radioactive waste is produced with a half-life of 12 years, and it's estimated that fusion will be 3 to 4 times as efficient as fission. There have been several successful controlled explosions of fusion reactions by scientists quite recently. However, keeping the momentum going throughout the project is a major challenge. What do you think are the biggest challenges? We'll get into it further in a moment, but before we do, hit that like button and subscribe to this channel. In addition to the millions of degrees Celsius needed to superheat the fuel, the following superheated reaction is equally difficult to control. The plasma in the center of a fusion reactor must be very hot. This calls for an enormous quantity of power, frequently more than the reactor can provide. However, one aviation powerhouse, Lockheed Martin, has stepped up and offered an upgrade that will likely cause a major shift in the market. Lockheed Martin puts it this way: it's common knowledge that our skunkworks group spends a lot of time on the cutting edge of innovation. While trying to create an endless energy source, engineers here are taking cues from the sun, the largest natural fusion reactor. Inside the center of the sun, nuclear fusion happens as a natural process, and as Lockheed Martin detailed in 2018, their future ideas will internalize this same procedure. A small magnetic storage device. This allows for a measured discharge of energy, generating usable energy that can be used for useful purposes. Skunkworks method, which has been refined over many years, has at least the level of development required to rank it as a high beta idea. In reality, it is predicted that the newest version will make the gadget 10 times smaller than its predecessors, maximizing its potential or making extensive use of the magnetic field's pressure. Therefore, the firm believes it can rapidly develop fusion technology. A smaller gadget also needs less time to design and build. However, the business anticipates replacing a gadget the size of a building with one that can be transported on a truck. This little fusion reactor's output heat will power turbine generators using plain old heat exchangers in place of the combustion chamber. In the same vein, electricity or propulsion power may then be produced by the turbines and used in a variety of contexts. Applications for such a feat of ingenuity might vary from fueling portable communities with up to 100,000 residents to providing everyone with access to clean energy and water. As a side note, this innovation has the potential to drastically cut down on space travel times. New vessels, however, will probably have secure generators in the near future, and it won't be long until we have airplanes with infinite range and unrivaled longevity. Within a 5-year period, the corporation has guaranteed that it will create a prototype. They have the patents in hand as well. The fundamental principle of today's turbojet engines is to draw in air from the front of the vehicle. The air is heated as it goes through a turbine and then compressed and ignited with fuel at roughly 1200 degrees Fahrenheit, generating forward momentum as it leaves the nose. The incoming air in turbofan engines is also divided in half. Half travels to the core compressor, while the other half flows to the turbine, while the remaining portion starts the propeller spinning, increasing speed and acceleration. However, the current engine's combustor components are amenable to replacement by the use of heat exchangers to provide the same thrust without the use of fuel. Lockheed Martin received a patent in 2018 for a technology it calls encapsulating magnetic fields. According to the designer's estimates, a single reactor could operate continuously for 100 megawatts of electricity generated each year on only 25 pounds of fuel. By comparison, a Boeing 747-400, a widely used passenger plane, has a fuel consumption of about 5 gallons, about 19 liters per mile, which is about 2.1 liters per kilogram. Let's assume that the plane maintains an average speed of 900 kilometers an hour, about 560 miles per hour, during a 10-hour flight. The fuel consumption per hour then comes out to 900 km multiplied by 2.1 liters per km is 1,890 liters per hour. The fuel consumption during a 10-hour flight is thus a total of 18,900 liters. On average, there are 100,000 passenger flights per day worldwide, so calculate for yourself how much fuel is thus consumed per day. However, nuclear power was not without its drawbacks. In order to fit aboard an aircraft, the reactor would have to be much smaller than usual, which means it would produce a lot more heat. There is a danger that the reactor, and the aircraft with it, may melt under the intense heat. This would result in a radioactive blob of liquid metal hurling towards Earth. Protecting pilots from the nuclear reactor's radiation was an even bigger challenge. A plane that accidentally kills its pilots isn't much use to anybody. The reactor required robust, heavy shielding to protect the crew from radiation. However, the aircraft had to be as light as possible before takeoff. Effective protection seemed to be incompatible with air travel. For the foreseeable future of aviation, the idea of nuclear-powered aircraft engines is both exciting and complicated. Because of its potential for greater efficiency and a longer range, it might significantly alter long-distance flights. However, it also prompts serious worries and inquiries about its potential risks, environmental effects, and ethical implications. When it comes to energy density and long-term sustainability, nuclear propulsion has enormous potential. But the aviation sector must approach it with caution. In order to win over the public and the regulators, it'll be crucial to deal with the inherent dangers and provide fail-safe safety measures. Collaboration and communication between scientists, engineers, politicians, and the general public are essential as we consider the feasibility of nuclear-powered flying. Navigating the obstacles and realizing the full potential of this groundbreaking idea will require extensive study, rigorous testing, and open communication. Whether or not nuclear-powered aircraft are ever built, the idea has prompted important discussions about the industry's future and our collective duty to strike the appropriate balance between advancement and prudence. Let us, as we gaze into the future, envision air travel that is not only fast and easy, but also secure, environmentally friendly, and considerate of the world as we all share. In summary, this concept has gigantic potential, but there's a lot to be done before we can actually use it efficiently, safely, and sustainably. However, this future is closer than we think. Development is so rapid that we expect new updates soon. What do you think? Is this new technology upgrade a boon or a bane to the world? Let us know your views in the comments below and subscribe to our channel for upcoming videos.